When I retrofitted my RV with solar panels, batteries, and inverters, my goal was threefold: to power the trailer while camping, to charge my electric vehicle while not camping, and to have the capabilities to power my entire house in an emergency when the electrical grid fails. It has been working fantastic for all those needs, but one of its limitations is that the electrical system is tied to the trailer itself, and the trailer is a big vehicle that can't be taken everywhere. Plus, building out that system required that I learn how to assemble the entire system at the component level, which I enjoyed, but not everyone is interested in doing that. And that's where the product of today's video comes into play. OUPES sent me their Mega One portable power station with their 240 watt, 20% efficient fold-out solar panels to evaluate and review. They sent me these products to review, but they didn't dictate that I must say anything specific about their product, and I'm just here as an unbiased third party to run this device through its paces and show how well it performs. Stick around until the end of this video where I'll get into the details of the pricing, including the $250 discount or 35% off during their launch sale coming up in just a couple of days. First off, let's talk about what a portable power station is. It's simply a device to store and deliver electricity that is either alternating current electricity or direct current. It's basically a battery which has the necessary electronics to be charged from and provide power to a variety of sources, both AC and DC. Historically, in my experience, the majority of people in the world use generators for electricity when the power grid is unavailable. There is a lot of variance and options in the generator market, but generally it is an internal combustion engine that uses primarily either gasoline, propane, or diesel to run the engine, spin an alternator, and make electricity. There are some drawbacks to using such a generator, which, in my opinion, is mostly the loud sound that it makes, but a close second is the toxic fumes that come out of it. Then there is the heat, fuel costs, maintenance costs, etc. Many people refer to portable power stations like the Mega One here as solar generators, which in my opinion is only correct if it has solar panels with it. If you're referring to just the power station itself, then it is not a solar generator. But I'll just get off my soapbox now. The beauty of a solar generator is that you're able to produce electricity from the sun silently, and there's no maintenance involved while using it over its entire lifespan, other than perhaps wiping dust off of the solar panels periodically. In my experience, one of the best use cases for a portable power station is powering it with solar panels while camping off the grid, and I love that it can also be used as a source of power for emergency preparedness. Solar generators are especially awesome for emergency preparedness because they are silent, which is exceptional for operational security or OPSEC. And assuming the sky hasn't been scorched like in the Matrix, the sun will continue to be there powering your device for years to come instead of regular generators, which require fuel to run, and if you can't acquire that fuel anymore, you're out of luck. Regardless, it's always nice to have a variety of options to fit different needs, and I love the versatility of a portable power station. In forums online, I often hear of CPAP machines as the reason people run generators all night, which is a huge source of contention in the camping community due to the noise keeping neighbors awake and destroying the quiet of nature. We camped next to that very situation down in Arizona on a past trip, which I'll put a card to above, and it was not pleasant, but unfortunately there wasn't space in that area to spread out to get away from their generator noise. A quick Google search says a CPAP machine uses up to about 100 watts. With 1,024 watt-hours of energy, the Mega One could power a CPAP machine for about 8 to 9 hours, including efficiency losses. OUPES has multiple portable power stations in their lineup, and the Mega One is their newest and smallest power station in the Mega lineup. This is the website for the Mega One. Right now I wanted to just go over some of the high-level stats here that are listed on the website. So continuing down here, you can see it's 27.8 pounds. This is not very heavy when it comes to portable power stations or even generators for that matter. You can get bigger ones and they have wheels and handles that you can roll along the ground. So compared to those, this one is quite lightweight. This has the lithium iron phosphate battery chemistry, and they have it rated for 3,500 cycles to get down to 80% of its original storage capacity, which is pretty industry standard in my experience. And then here it's just listing out its inverting output capabilities is 2,000 watts. Over here it's just listing out a bunch of different devices you could power from this, but obviously the options are pretty limitless. Really the limiting factor here is not so much the wattage output, because keep in mind a standard household outlet can't even go up to 2,000 watts. at least not a 15 amp circuit. The limitation is more the storage capacity, like how long are you running these devices for at up to 2000 watts, because obviously at 2000 watts it would only last for half an hour or less. But if you have other power sources like a generator or solar, then the limiting factor is where you're getting that additional energy from. It's expandable up to 5,120 watt hours, which would of course be connecting one of their external battery packs to it to get that additional battery capacity. And then you can charge this really quickly at minimum time of 60 minutes. So solar panels plus plugging it into a AC outlet at the same time is how you're going to be able to be charging this that quickly. And then 5 ways for recharging. So this is where I think that portable power stations really come in clutch, because they're so versatile in the ways that you can use them. So you can charge at 2 different speeds at fast and slow charging from AC inputs. And then solar input, you can have it connected up to 800 watts of solar. I'll do a test later of how long it takes me to charge it with 240 watts solar panels that they sent me. And then here AC plus solar input, so 2200 watts combined, would charge it in that hour. And then the car input, you can it takes voltage from 12 to 15 volts at 8 amps, and then it would take 12.8 hours to charge it in that case. I tested this in my Tesla Model Y, which has a 16 volt low voltage system, and what I found was that the voltage, once it pulls the 8 amps, quickly drops down below the 15 volt limit here, so that's not a concern. And then generator is compatible with their smart generator. And then outputs wise, you have 4 AC outlets that each independent go up to 2000 watts, which is fantastic. We have 2 USB-C ports that are 100 watts each, 4 USB-A ports which are up to 18 watts each, 1 car outlet, so that's just a standard 12 volt power socket, or cigarette lighter port if you're familiar with that terminology, and that is 120 watts maximum. And then they have 2 DC 5521 ports. I don't have devices that use that. And then smart app control. This is really helpful to be able to connect to it and see what the wattage is, and obviously what your inverting capabilities are and information in there. And you can either use Bluetooth or Wi-Fi. Enough talk, let's test this thing in the real world. To demonstrate where a portable power station is really handy in a campsite situation, I wanted to show you this site we're at right now. You can see that is our truck and trailer over there, and that is the closest area that cars are allowed to be. Normally we power our camping from our trailer, and when we're boondocking, that's not really a big problem at all. You're in a wilderness setting and there is plenty of room to camp directly around the trailer. Sometimes we have run really long extension cords from the trailer somewhere else, but in any case, in this situation, it's way over there. If we were to run an extension cord, it would have to come all the way across this stream right here, which obviously is fraught with danger right there. And then coming up over this way is the picnic area of this campsite. There is no electrical service here, so if you want electricity here, that's what we would have to do if we didn't have this portable power station. But now we have a variety of shade here, but we have a sunny spot here, and so I have set up the solar panels here. So right here you can see that we're getting 200 watts from the solar panels, and then I have this 12 volt power plug is powering this TesFridge right here. It's currently at 28 degrees. I guess it's a little overcompensating because I currently have it set to 36 degrees. In any case, this fridge is being powered by this portable power station. If we open this up, you can see we've got some food in here for the campsite. The compressor just cycled on for the TesFridge right here, and you can see now it's pulling about 50 watts. The solar is producing enough to power the fridge and still charge the battery. And then we have right here 2 of these PD100. So one of them is going to this power cord right here. We're currently getting 50 watts. And then additionally to that, I have just plugged in my cell phone right here. It's charging off of the secondary port here. And then the third thing that I have plugged in, or I guess fourth thing, is this right here, is a standard AC outlet. So I'm going to turn that on right here. So that I just turned on the inverter. And now what that's plugged into is this mug right here. So this is an electric mug. I'm going to go ahead and push the power button. And now that is turned on, and you can see I've got some water in here. So if you wanted to be able to boil water from the electricity from this power station, come over here. And now you can see the power consumption has jumped up dramatically. And you can see the power station is currently at 70% on the battery, but clearly our consumption is more than double the solar production of 203 watts. So that's going to start going down at this point. And it is estimating that if we kept up this rate of consumption, that we would only have 1 hour of consumption. But this can go up to 2 kilowatts, but we're still only a quarter of its maximum inverting capacity. This water is now just beginning a rolling boil, and it has been only just a couple of minutes. You can see over here it's still pulling 500 watts, and we're getting 162 watts of solar right now.
and the battery is at 63%. So it used a chunk of the battery, but you could actually do this several times and it would be just fine. And here's another experiment I'm doing. I right now just have the cooler, the TesFridge, plugged in, and I've charged this up to 100%. And so the fridge is pulling about 53 watts right now, and right now it is 5:50 p.m. as a point of reference. And so in the morning, let's see how much energy it took to keep the TesFridge cold all night, set to 36 degrees, and with some food in it. It is now the next morning, and we're eating breakfast, and the power station is at 77%. It is 7:22 a.m. And yet another use case for it, we have this mixer right here, which looks like it was made in the 70s. And it got powered by the power station. So overall, I'm very happy to have this solution now where I can take power with me to remote places where I can't get my vehicles to, where I was previously getting my electricity from before, primarily my trailer, but sometimes my Tesla. And now this I can take to places that I can't get the vehicles to, and I can still power lots of things. Another use case for a portable power station is, in the case of emergency preparedness, is for potentially grinding grain. So you see here we have the Country Living grain mill, and I've put 10 cups of wheat into it, and then down here you can see the battery is at 72%. So I'm going to go ahead and plug this in. You can see that the Country Living mill is consuming about 133 watts. So I'm going to let this grind this whole 10 cups right here, and we'll see how much of a battery percentage is left when it's done. It has been about 35 minutes, and you can see it's just barely finishing up the last of the wheat grinding right there. And coming down to the power station, we're at 61%. So it used 11% of the battery over 35 to 40 minutes to grind 10 cups of wheat in the Country Living mill here. Here's another test use case that I wanted to try out, because this is something that I've been wanting to do. As you can see here, I have the battery of my Talaria MX4, which is right there, my dirt bike, electric dirt bike. And when I take it on trips, I have it here on the back of the Model Y on a receiver tray here, a Mach 2 from Quicker Stuff. Something that I cannot do, or have not been able to do, is charge the Talaria off of the car. Now, typically in my normal dirt bike rides, I don't really need to. I use up the battery capacity and then I go home and it's 3 or 4 hours of riding and I've had enough. But if I wanted to, like if I was camping, for instance, and I had the time, what I can do here with the power station is I can plug it in to the 12-volt power socket on the Model Y here, which is actually 16 volts in this case. But you can see here that I'm currently charging off of the car. Right there, you see 112 watts is what it's inputting from the car. And you can see it's plugged in right over here on the side in the same port that the solar panels use. Now what I can do is I have here the charger for the Talaria battery. And of course I could do this while the Talaria battery is still in the Talaria. I don't have to pull it out to do this. I'm just doing this for demonstration purposes, and because often when I'm transporting it, I take the battery out anyway. And this would be nice to be able to put it in the car and then close the car for security purposes, or maybe if it's raining or something. So over here, now I can turn on the inverter, and that's going to turn on this fan right here, so you can tell that it will start charging. There it goes. So now it's beginning to charge the Talaria battery. What it's doing, obviously, is taking the majority of the energy from the battery of this Mega 1, but it's simultaneously also replenishing it to some degree, right? So 115 watts is coming directly from the Model Y, and 769 watts right now is coming from the Mega 1. So before, I wouldn't have been able to charge my Talaria battery at all, because the Talaria battery is not configurable. It always pulls that much energy. And that's way more energy than I could output from, say, if I had plugged in an inverter to this power port. As an example, I have this inverter right here that I use. This is a 300 watt pure sine wave inverter. So that's slightly less than half of what the Talaria battery needs to charge. And that's, it just, like I said, it's not configurable. I can't tell it to charge more slowly. It just pulls that amount. So with this gives me the surge power that the Talaria battery requires to charge, but I can also recharge this thing either from the Model Y directly or potentially from some other source. And also, obviously, I could have my solar panels deployed and they would be charging this Mega 1. In fact, the solar panels, I have a 240 watt solar panel array, and if it's a sunny day, I could actually be charging the Mega 1 at double the rate as from the Model Y. So there's lots of options, and that's what's really nice about a portable power station is there's lots of options for both input into the device to charge it. It gives you more options of things that you can power from it, at least temporarily until the battery is depleted, of course. In this case, it's estimating that it has 42 minutes of runtime at this rate of energy consumption before the battery would shut down. And in that time, I'll of course be able to charge this battery somewhat. Keep in mind, this battery right here is 2.7 kilowatt hours. This one right here is 1 kilowatt hour. So I'm not expecting to be able to just fully charge this all of a sudden, but being able to add some extra range while out in the boondocks away from civilization is definitely a plus in my book. This car can have pulled continuously about 200 watts, more like maybe 192. And I wish I could configure this to, maximize that speed, get up closer to the max anyway. It basically just shows the rate of charge from the car, but it's not showing how much longer until the battery will be full, which would certainly be nice to see on the screen. Another thing that we're going to be using the Mega One for is situations where we are out riding our e-bikes, and I have here 3 Greenger Saddleback e-bikes for my 3 daughters, and there are times where maybe we'll be riding away from our trailer and either of our Teslas, maybe with our truck, right? We have our dumb Ford F-250 truck over there, and it doesn't supply any electricity really that we could use. And so we'd be able to use this for that. So as a demonstration, I'm going to plug in one of the e-bikes, and you can see right there it's jumped up to 55 watts, which is about the rate that it charges them. So I'm going to plug in a second. There it goes. Yep. And now I'm going to plug in a third. This is how fast it would be able to charge all 3 e-bikes. And you can see here that the Mega One is estimating 2 hours at this rate of consumption, and it's at 53%. So that tells me it would take about 4 hours to drain it. Over here you can see that the battery is indicating 105 watt hours for each of those batteries, but there are some efficiency losses going through the inverter. So just because this is storing a kilowatt hour doesn't mean it's going to be able to charge these batteries 10 times. And I'm going to demonstrate one more e-bike that I will be charging with this potentially, and that's my conversion mountain bike here. This is a regular mountain bike that's just been converted over to being electric, and it has a BBS HD motor down there. That's a kilowatt motor. And then up here we have the EMBEV battery. This is about 1 kilowatt hour in this battery, so it's pretty gigantic. And I've got it plugged in right now to its charger down here, and then it is charging off of the Mega One at the rate of 247 watts. And here is yet another use case for emergency preparedness for the Mega One. We have here our Frigidaire garage freezer. It's about a 20 cubic foot freezer, and I've just set the Mega One right over here. And so right now I've plugged the freezer into the Mega One, and you can see right now the freezer, its compressor is on, so it's pulling 84 watts right now, and it's estimating that the power station can go for another 4 hours at 51%. Now right now the power station is not being charged at all, and if I were to be doing this in an emergency situation, I would have my solar panels deployed just outside right here. And then alternatively, another way I could use this is I could actually be plugging the Mega One into an AC power source, which is this plug right here, and we happen to have a plug right there for that. And this would be fully charged all the time, and then the freezer would be running off of it, and the Mega One is just doing the pass-through in that case. And this is functioning as a UPS, where the moment the power goes out, this will just switch over in milliseconds and continue powering the fridge. And here's a demonstration of that. You can see I've now plugged in the power cord, the AC power cord, and the power station is still ramping up its charge, but it's going to get up to about 700 watts. I currently have it configured to charge at the slower rate. And so now if I unplug it, and you'll notice the consumption right here was 62, and it's still 62. So the freezer didn't shut off or anything. It's uninterrupted, and we can periodically be charging the Mega One from either an AC source or solar panels or whatever. This is an example of a whole bunch of different electronics that I have that I would potentially need to power while I'm out on a trip. And most of these are camera related, but I just wanted to talk about kind of what's going on here and how much power these things draw, and also what we have as available power output options on the Mega One. So as you can see up here, it has 2 100 watt power delivery ports. Now that is fantastic that it's 100 watts now, because some of the previous power stations were 60 watts is my understanding, and so having 100 watts is a great improvement on that. Now power delivery can go up higher than that. This cable right here, for instance, is rated for 240 watts. This one is rated for 100 watts. As a demonstration, I wanted to show over here I have my laptop, and its power port, as you can see right there, is a USB-C power port. So right here is the cord that came with the laptop.
and let's see how much power the laptop actually needs when it's pulling everything that it can get. So there, I think, is about what we're going to see is about 140 watts is what I saw it peak at, 141. 100 watts is not going to be sufficient to completely power my laptop with as much power as it would like to get, but that right now it's charging the battery. So the actual running of the laptop does not need to be 140 watts. It's just that's how much power it could potentially take. So if I come over here now and unplug that and then plug in this cord. So it's really hovering there at the high 80s, and I've done this test prior and left it on for a while, and it just hung out here at 89 or 88 watts. What I was wondering is it displaying it properly, because it's supposed to be able to go to 100 watts according to that label right there. So let's try this cord right here, which is rated for 100 watts, and you can see here it's hovering at about 86 watts. And then if we look over here, it's showing 87, 88 there as well. So really it's the same, and it's throwing a notice up here saying slow charger. So it is not getting the full 140 watts that it wanted, but it is taking 89 watts. And I have found that it is actually able to charge the battery of the laptop without too much of a problem. But if I'm doing heavy video editing, then the battery slowly declines. But we're talking like 50% over the course of 8 hours of video editing. So it's basically just barely breaking even with this level of power when the laptop is being heavily taxed. So I would say this actually does work just fine to power the laptop. It just isn't going to charge it quickly, if especially you are using the laptop heavily. So the question is, why isn't the Mega One giving out the full 100 watts on these ports? I don't know. Now let's turn our attention to all of these other cameras. So just in brief, I have a FLIR thermal imaging camera. I have my Sony a6600 mirrorless camera. I have my drone controller, that's a Mavic 2 Zoom. Here's the battery for that Mavic 2 Zoom. Here's the charger for that. This is my DJI mic Gen 1. Here is my Action 3 from DJI. Here is a Insta360, and then right here is my cell phone. And then I'm filming with my Osmo Pocket 3, which I'll now switch over to my cell phone to show it. And here is the DJI Osmo Pocket 3 that I use for filming a lot of my videos. As you can see, the battery is at 13%, so it is charging at maximum speed, and its maximum speed is 33 watts, which is really incredibly fast. I have found that it will tick up 1% here about every 10 seconds, give or take a couple of seconds. But I guess what I wanted to demonstrate more than anything is I have a lot of things to charge, and I'm not using all of these at the same time, but there are trips where I'm definitely using bunches of them throughout the day, and at the end of the day I need to charge them all up, and having to cycle through just 2 USB ports would be pretty tedious. All of these are USB-C except for this right here, the Sony a6600. It's using a micro USB port. Now that being said, I definitely have some cables that are USB-A, which is this type right here, to USB-C, so I can still use these 4 down here. So basically we got 6 ports to work with, assuming you have all of the proper cables. Now obviously I would potentially be using all 6 of these ports over here, as much as I have cables and devices that I need to charge. But what you can also do is just use an AC port and then use a power supply like this. This power supply is awesome. I've been using this for a while. Every single port on here is dedicated to its maximum wattage, so there's no sharing of wattage. So it has 5 USB-C ports right here and then 3 USB-A ports. And right now you can see I have all the cables plugged into all of these devices you see across here. So what I can do is come up here and turn on the inverter, and then immediately all of these things are going to start to charge at the same time, except for this drone battery. Now this drone battery has its own charger. It's its own proprietary connection right there, as you can see. And this is the power supply for it, and it requires the AC plug. So I'm going to go ahead and plug it in as well. And these things are kind of picky on the power that they'll accept. It has to be pure sine wave, and definitely it is in this case. I have now plugged in everything, and I have it all charging simultaneously, and then also I have the laptop charging over here, and it's pulling about 62 watts. And so if we look over here, you can see 183 watts going out to everything there. If I unplug the laptop, you'll see that this will drop down a pretty good chunk because it's pulling the most. But I definitely need to be pulling about 113, 114 watts to be able to charge all these things at the same time. Now if I unplug my drone battery, then that's going to drop down again as well. The drone stops charging, and now it's 47 watts that's going out to all these different devices. And they're pulling varying degrees right now, just depends on how discharged they are. And I think most of them are mostly charged at the moment. I just wanted to demonstrate the versatility of being able to plug them all in here or to an external power supply that is coming out through the AC port, and that works as well. And I definitely have enough cables. I could be charging them all off here, but I would only be charging up to 6 devices at a time, but I could expand that with this, and then you can charge lots and lots of things all at the same time. I've plugged it in to just the standard household outlet over here, and you can see it's showing 1350, 1356 watts charge speed. So it's not the full 1400 that it said it would. If I come over here, my device is a little bit on the overloaded side, it looks like, but it's showing 1481. Something I wanted to talk a little bit about is this switching between fast and slow AC charging. So this is the AC charging methods, and down here it's talking about how you can configure it to charge at either 700 or 1400 watts. And you might ask, why would you want to do that? Why wouldn't you always want it to be a maximum speed? And I would say maybe slow it down just for maybe battery longevity. If you don't really need it to be in a hurry, then if you charge or discharge batteries more slowly, it's easier on them long term. And then potentially the source that you're plugging it into, 1400 watts, is pretty high. It's going to be consuming the majority of a 15 amp circuit, for instance. And if you have other things running on that circuit, you might want to go at 700 watts so that you don't cause the circuit breaker to trip. So the thing I wanted to talk about up here is that the method is kind of convoluted. So let me demonstrate. So you push this IoT button, and down here you push this DC button, and you push them both at the same time, although I think you need to push this one slightly before. So I'm holding them both down. There we go. So then it says set, and you got L here for low. If you push IoT, it'll toggle between high and low. So right now it's at high, so I'm going to switch it down to low, and then you got to press the power button and hold it down for a few seconds. And then it says you suck. No, just kidding. It says success. And then you press and hold the power button yet again. And then finally, it goes back to the normal menu. Now that won't work, meaning you can't do what I just showed you if you are currently charging it. So you have to make sure that it's unplugged from the wall, and then you'll be able to go through and change those settings. And now I have plugged it into the wall, and it's charging at the low speed, so you can see it's pulling 670-ish, and then over here it's showing 706 watts. And so I believe that this number is just simply a reflection of what is going into the battery, and this meter over here is indicating how much it's actually pulling from the wall, and then the difference is just the efficiency losses of converting from AC to DC. Now it is time to test the surge capabilities of this Mega 1. As you can see right here, it indicates 2 kilowatts maximum, and I was trying to think of what device I could use that uses that much, and I couldn't really think of anything. I realized, well, my best device that I can use is my Tesla Model Y here. So I plugged in the mobile connector from Tesla, and it has a grounding fault because I don't have a neutral and ground bonding plug. But when I try this mobile connector, which is, you can see right here, Pi and Power. I did a review video about this some time ago, and I could put a card above to that video. It is green, so it's ready to go without that bonding plug. So what I'm going to do, I've charged this up to 99%, but my test initially is just, I'm going to plug it in, and then I'm going to be slowly adjusting the amps over here one at a time to get this to get to its limits and trip. So first step is to plug it in. And at this end of the plug, I have the J1772 to Tesla adapter plugged in. This is now green, so it's charging, and it's 600 watts basically. So now I'm going to come over here, and you can see right here, I can adjust the amps. So I'm going to go 1 amp up, and you'll see over here, it should go up 120 watts because this is 120 volts, and I'm just going to keep increasing the amps. So it's at 800, now I'm going up to 8 amps on the Tesla. It's going to climb up here, so now it's 962. I'm going up to 9 amps in the Tesla, and now it's 1082. So that's only half of the Mega 1's capability. So I'm going to go up a little faster. So I'm going to go up to 12, and actually that's the farthest that it will go. If I come over here, you'll see that because of the connector type that I have it plugged into, the Pi and Power mobile connector is limiting me to 12 amps because it's meant for a 15 amp circuit, and this is the 80% rule that it's following. Okay, I figured out a way to bypass that limitation. So what I've done is I've put the NEMA 1450 plug here on the Pi and Power mobile connector, and then that is going to be plugged into this, which is a NEMA 1450 to TT30 adapter. And then that is going to be plugged in here, which is a TT30 to NEMA 515 adapter.
So with all three of these combined, I will then be able to plug it in here and I'll get up to 2000 watts. I've plugged in the generator to the mobile connector, and now I've plugged in the car to that mobile connector. I just heard it click over here. So you can see I've got this kludge of adapters going on. And then if we look up here, we can see that the wattage is just starting to ramp up, and it stopped there at 600 watts. So I'm going to bring this back up to 10. And now it is at 1200 watts. And now I'm going to 11 watts in the Model Y. Now it's 12. This is where we left off before. And now I'm going to go up to 13. 14 amps in the Model Y. So it's pulling 1683. 15 amps in the Model Y. Oh, it hesitated briefly. Now it's 17, so 1800 watts. So you can see right here, I've indicated 16 amps, and that's what it's pulling. According to that right there, it's pulling 16 amps, 119 volts. And you can see over here, the power station is providing 1910 watts. So I'm going to go up one more amp to 17 amps on the Model Y, and it should trip it so that it shuts off. Or I guess maybe it has some surge capabilities. Let's find out. All right, there we go. We're at 2 kilowatts on the power station. That battery is plummeting quickly. But look at that, it's holding on at 2 kilowatts right there. Here we're at 17 amps, and you can see over here it's pulling 2 kilowatts at 17 amps, 119 volts. So the voltage is staying up really high, which is great. So I'm going to adjust this to 18 amps, and let's see what that looks like. Look at that, 2117. Now I'm going to go up to 19 amps on the car. Oh, you saw that. It peaked at 22 very briefly and then cut out. I'm pleased with that. It sustained 2000, no problem. Now let me be clear about this experiment with the Model Y. It was all about just testing the max power output of the power station, and I was not trying to demonstrate the ability to charge the car from the power station. Now obviously you can. It just doesn't make a lot of sense to actually plan on doing it. So the power station has 1 kilowatt hour of capacity. The Model Y has about an 80 kilowatt hour battery pack, but only about 75 kilowatt hours are usable. So you're not going to be adding more than, you might get a % added, but it's not even a full % added to the car from depleting the entire Mega One power station. And in addition to that, you can see right here that our all-time range on this car, the odometer is at 16,709 miles. Over that distance, we have used 347 watt hours per mile on average. If this was at 333 watt hours per mile on average, you would be able to get at least 3 miles per kilowatt hour, meaning the entire Mega One battery pack would give you 3 miles of range. If you drove really conservatively and you got down to 250 watt hours per mile, which is certainly doable if you drive slowly, then you could put 4 miles of range into the Model Y from the Mega One. So it's not really good for this use case. It just doesn't make sense for electric vehicles because they use a whole nother order of magnitude of power, and the Mega One does not have enough electricity on board to really make much of a difference on the range of a Tesla, or an electric vehicle. But it can give you 3 or 4 miles is all. And also, to be clear about this, I know a lot of people that their average is much lower than that. This car is primarily used for road trips, and we've done road trips where we have a bike rack on the back, or we have a roof box on the roof, stuff like that, towing a trailer. So this, and also we're usually driving like 80 miles an hour or more. So this is reflective of that. We don't really drive this car really conservatively just in the city for long periods of time. Another use case for the Mega One power station is when you want to be running Starlink out in the middle of nowhere. You can see here we are in the mountains in Utah, and I'm here camping with my daughter Lucy in the back of our Model Y on the Lost Horizon mattress, and we're doing a review of that. I'll put a card above to that video. But on the subject of the portable power station, I've charged it up to 100%, and I'm going to turn on the inverter right here. Here the energy consumption is jumping up and down. I don't know if you saw that, it was spiked about 50 or 60 watts for a moment. And I'm sure that that is it just doing its boot up sequence. There it peaked at 100 watts briefly. The satellite has now tilted to its desired direction, and you can see it's pulling to basically 50 watts. So at this rate, it's estimating 10 to 12 hours before the battery will be completely depleted. As you can see, I had it charged up to 100%, and I'm going to leave this on all night and we'll see where it is in the morning. It has now been 12 hours and 15 minutes since I plugged in the Starlink dish to the Mega One, which was at 100%. and you can see it's now down to 4%. Keep in mind, the ambient temperature right now is 42 according to the Tesla, and it was 38 degrees a few minutes ago. So that means potentially some of the usable capacity of this is unavailable because it's gotten cold, because it's just been out here on the ground like this overnight, but probably not a ton. In any case, it's really awesome to be able to have internet out in the middle of nowhere. And if we ever come camping with our truck, which cannot supply electricity, then this would be our method for doing it. But if we are camping in our Teslas, then normally we would just power the Starlink dish from the 12-volt power port that's back here in the corner of the Model Y. But it's nice to have options, because sometimes we want to be able to camp farther away from the vehicles and where they can park. I'm going to do a test today to see how long it takes to fully charge the Mega One from the solar panels that they sent me, which is 240 watt solar panels. So what I'm doing right now, just to get the Mega One battery down quickly, is I'm just charging my Model Y with it. And right now the Model Y is pulling 5 amps at 120 volts, and it's down to 1%. So any moment it's just going to cut out and not have any more power to give the Model Y. And then I will plug it into this and we'll see how long it takes to charge. Right now it's just past 8 o'clock in the morning, so we've just barely got some morning sun, and then I'll let you know what time of the day it is done charging. I've set up the panels here in my backyard in about the only patch of sunlight that is available currently, although it's rapidly expanding every moment. And obviously they're pointing directly at the sun. And then the power station, you can see, is down to 0%. So over here on the side, plugging them in. Now it's going to start to register the incoming power, and the charge controller starts low and then ramps up. And while the charge controller is ramping up, I thought I'd point out the reason why I have these cinder blocks underneath the panels over here is because having panels directly on the grass casts a little bit of a shadow across the bottom part of the panels, and you can see there is even a little bit right there. I'm not totally sure where the panel begins and ends. You can see there's a silvered line right there. In any case, you don't want any shading on any part of the panel. At least I don't, because I want to make sure it has maximum solar yield. The charge controller is stopping at about 185 watts at the moment, and I'm sure it'll continue to ramp up. And I'm going to be adjusting the panels throughout the day to make sure that they're still pointing at the sun. The battery's now up to 24%, and we're getting 208 watts of solar. And it's just a little bit later. It's now 9:46, and I started this at about 8:30. So it's been a little bit over an hour and a half. And then also I wanted to point out that I have connected the Mega One to the mobile app, and it's connected to Wi-Fi so that I can monitor this from inside the house. So here it's showing me the same wattage of 207, 208 watts as what the charge controller is showing over here. And then as well, the 24% on that battery there is reflected in the app over here on the side. I changed the orientation to be sideways, and then I have the cinder blocks on their sides, helping to angle it better towards the sun. And actually the output did not change a whole lot. It's 198. I've been experimenting with trying to make sure this is pointing directly at the sun as good as possible. And here's an example of something I tried. This is just, from a toilet paper roll, and I just set that there on the panel and then see how the sun falls. And you can see right now there's a little bit of shadow being cast back there, so I can move the toilet paper roll and kind of see how much of an angle I still need to go to get directly at the sun. So it's been actually really good for most of it. It's just that the sun is constantly moving, and right now these panels could be adjusted a little bit. But what I have found is when I've been adjusting them, a little bit of adjustment doesn't actually make a huge difference, but generally pointing at the sun within, say, 15 degrees is just fine. Just seconds ago, it changed over to 100%, and you can see the charging rate completely went away. And looking at my phone here, it is 1:50 p.m. The next test I'm going to do is a capacity test. So you can see here I have charged up the Mega One to 100%, and then I have my kilowatt meter here plugged into it with a mobile connector. And right now the mobile connector is actually just pulling 1.79 watts on its own. And so I'm going to plug this into the car, and I'm going to discharge all of the energy from the Mega One into the Model Y, and I'll see how much energy actually passes through the kilowatt meter, and I'll be able to see what the efficiency is of the 1 kilowatt hour of battery in here and how much of that actually goes into the device that you're powering. So right now, charging the car is not the important part. The important part is how much does the electricity does the kilowatt meter measure coming out of the battery. And when I say how much, what I mean is if I go up here in this device up to this is measuring the kilowatt hours coming out. The Mega One battery is now down to 1%, and before the power cuts out on the car, I just wanted to show a brief update here that it just indicates 1 kilowatt hour. It doesn't give us very much information. I wish we had,
more details than just the 1 kilowatt hour, but it shows that it's taken on 1 kilowatt hour and it's still pulling the same amount of energy that it's been this whole time. And the Mega 1 has been going for a lot longer than I expected after it got to 0%. You can see the wattage is dropping, the voltage is down to 117. The cooling fan speeds are changing tone. And there it goes. The power station just finally shut off, and you can see that over here that number turned off. And then also I heard the car disconnect, so it's white light there. You can see here it had a total of 0.88 kilowatt hours come out of it into the Tesla, and that was over 89 minutes. Here are some additional details about that charge from TeslaFi, which is the API tool that I use that connects to the Tesla API. It added 0.52 kilowatt hours to the battery. It used 0.89 kilowatt hours though out of the Mega 1. But because of conversion losses going into the battery pack, it's actually only half a kilowatt hour. So that's 58% efficiency, and that's not great, but that's what it is in this particular case. Over here, it's estimating that we added 2.17 miles, and I'll go ahead and estimate that that's probably roughly correct. And now what I'm going to do is plug the cord into this electric meter that is now going to start charging the Mega 1 back up to 100%, and I'm going to see how much electricity goes into it. Now keep in mind I have this set to the slow charge rate, so it should be charging at about 700 watts. But really what I'm interested in is just the overall amount of energy that it takes to charge it, as well as how much energy can come out of it to power devices. Right here you can see it's indicating that it's charging at 650 watts, and over here that is indicating 692 watts going into it. So there's a little bit of an efficiency loss going from AC into the DC battery over here. It's now been 69 minutes, and you can see that it is now pulling 735, and over here it's indicating that it's putting 690 or so watts into the battery. As the voltage is increasing in the battery pack, which it's at 83% now, then it's able to pull more and more power. It has been 83 minutes and it just barely turned to 100%, but it is still charging. As you can see over here, if I switch back to the watts, it's still pulling most of the watts. Right now, it has consumed 0.99 kilowatt hours. I've decided to go ahead and call it. You can see it's been going for 116 minutes, and it has pulled 1.15 kilowatt hours through this wall outlet. Right now, it is pulling 17 watts still, so it's just barely doing a little bit of equalization of the battery pack. But I feel like obviously the majority of the energy has already been transferred. It just says 100%, nothing else to show over here. So anyway, yeah, I think that's interesting to see how much energy it has consumed in order to charge the battery pack. And considering that the battery pack is 1,024 watt hours according to this, that's actually fairly close. You know, you have a little bit of efficiency loss going on. I hope this has been helpful to learn about the Mega 1 portable power station and see how well it works. I love the Bluetooth and Wi-Fi capabilities to be able to monitor the system remotely. I love the versatility of these power stations because they can be used in many different ways. If you power the Mega 1 with solar panels and a small enough electrical load so that the battery doesn't die during the night, such as a freezer, you could keep providing electricity to those devices continuously for many years if needed. I sure hope you don't have a grid down situation for years, but I think you get the point of the versatility of the Mega 1, especially when combined with solar panels, which you have to purchase separately. And note that the solar panel connections are standard MC4 connectors, so you can power the Mega 1 with third-party solar panels. You don't have to only buy OUPES solar panels. The MSRP price for the Mega 1 will be $699. But the launch pricing starting on September 10th is $200 off, and if you pre-order a Mega 1 for $1, you can get an additional $50 discount for a total launch discount of $250 off for a final price of $450 at launch. I've put a direct link to the Mega 1 in the video description below, and if you use the discount code ETA, it'll give you 5% off anything in the OUPES store. When I use the Mega 1 on future trips, it'll show up in future videos, and I'll share how it's working for us in those situations. Feel free to subscribe and change the bell notification to all to get automatically notified when our next video drops. Thanks for watching, and I will see you in the next video. The kids have been having lots of fun drawing with their sidewalk chalk, and then they are going up this sidewalk. Okay, Claire, which one's yours? Oh, the frog, I see. That's great, Lydia.
Into a table.
Kermit the Frog sitting at a table.
Yeah, so I didn't have to draw his legs because it would be hard. So the table is covering his legs.
I see, that's good. Nice, Lucy. Looks beautiful.